Hey, all you cool cats and kittens. Here we go. 1.2, we're going to be talking about the operations and compositions of functions. So how do we combine those functions? So in our first little box here, it says we have two functions, f of x and g of x. And you should be familiar with that notation for a function, f of x and g of x. There are four operations that we're going to do, and they are our basic operations: adding, subtracting, multiplying, and dividing. And so if you notice, the notation that we use is that we'll say f plus g of x. F plus g of x. That is the same thing as taking f of x and adding it to our g of x, combining like terms and leaving it as is. We also have f of x minus g of x. F minus g of x. F of x minus g of x. Same thing for multiplication and division. So make sure you are okay with those notations, that whenever you see the f and the g together, you know that you are multiplying those two functions together. When you see it in that division bar, you are dividing those two functions together. Remember, when you're dividing, your denominator can never equal 0, so just be aware of that. It could be g divided by f of x, and we wouldn't want f of x to be 0. It's whatever is in your denominator cannot be 0. Okay, so pretty straightforward. You're either adding, subtracting, multiplying, or dividing those functions together. So here we go. In example 1, I give you some f of x. It is 1/3 x minus 2/5. And then I give you g of x, which is x squared minus 5. And I want you to find the following using those two functions. So anytime we see an f of x, we're going to use this 1/3 x minus 2/5. Everywhere we see a g of x, we're going to use that x squared minus 5. So in the first one, all we're doing is adding. So we're taking our f of x, 1/3 x minus 2/5, and we are simply just going to add our g of x function, x squared minus 5. You know, at this point, we are just combining like terms. I only have one x squared. I only have one x term, and that's a positive 1/3 x. Now, I do have two constant terms. I have the negative 2 over 5, and I have the negative 5. Well, to make my life just a little bit easier, I'm going to take this negative 5, and I'm going to write it as negative 25 over 5. Why do you think I would do that? Well, I want to combine it with my negative 2/5. So now that they are like fractions, I can simply just combine my numerators. You know, when you're adding or subtracting fractions, and they have the same denominator, you can just work with those numerators. So I have a negative 2/5 and a negative 25 over 5. So of course that will give me a negative 27 over 5. That fraction cannot be reduced. Nothing else can combine. So boom, there's our answer. Okay, I know it might look ugly, it has some fractions in there. That is okay. We are simply just adding those two functions together, and this is our answer. Okay? Now we're moving over to part B. We're going to do the same thing. We're just going to subtract. So be very careful with subtraction. Whenever you go in order, I am subtracting that g of x. So everything in the g of x function has that negative in front of it. So you can distribute that negative if you want. That's probably the most ideal thing to do. So I'm going to write it out in order. I take my f of x, 1/3 x minus 2/5, and I'm minusing all of g of x, x squared minus 5. So I need to distribute that negative. So I'm going to rewrite it as 1/3 x minus 2/5 minus x squared plus 5. That way I know that I'm subtracting a negative or subtracting the positive correctly. Okay, and here again, I'm just combining like terms. There's only one x squared term, and that's a negative x squared. There's only one x term, and that is my positive 1/3 x. I have those two constant terms, the negative 2 over 5 and the positive 5. Again, we know that positive 5 is the same thing as 25 over 5. So now I'm combining a negative 2/5 with a positive 25 over 5. And so that's going to give me that positive 23 over 5. Cannot combine anything else, cannot reduce any fractions, so I leave it as is. If you want to turn that into a mixed number, that 23 over 5, if you want to write that as, 4 and 3/5 or whatever, that's totally fine, but you don't have to take that extra step. I'm not going to take that extra step. I will always leave my fractions as reduced and proper, unless stated specifically in the directions to change it to a mixed number or a decimal or something like that. So unless it just makes you incredibly uncomfortable, I would just leave it as is. Okay? Moving on to C, and we are multiplying here. So we have our f of x times our g of x. So I'm taking my f of x, 1/3 x minus 2/5, and I'm going to be multiplying that with my g of x, which is the x squared minus 5. So because I'm multiplying two binomials together, I'm going to use that process of FOIL. First times first, outer times outer, inner times inner, last times last. Some of you learned FOIL in Algebra 1 or 8th grade or whatever. Some of you used a box method. Some of you used something else, maybe, I don't know, but you are multiplying two binomials together. And so the way that I learned it way back in the day was FOIL. First, outer, inner, last. So my first times my first. What is a 1/3 x times an x squared? Well, that's going to give me a 1/3 x cubed. Remember, when you multiply things with exponents, you are adding those exponents. So x, the 1/3 x, that technically has an exponent of 1. When I multiply it to x squared, I'm adding those exponents together. That's why I get the x cubed. Okay? Then I'm going to go to my outers. So that's going to be the 1/3 x times the negative 5. Well, 1/3 x times negative 5 is a negative 5/3 x. Then I'm going to go to my inners. My inners is the negative 2/5 times the x squared. So that'll be easy. That's just negative 2/5 x squared. And then I go with my last. A negative 2/5 times a negative 5 is going to be a positive 2. Those 5 cancels each other out. A negative times a negative is a positive. At this point, I want to make sure that I cannot combine any like terms, and I can't because I do not have any like terms. This is your final answer, and it's okay to leave it like this. However, I would really like for you to get in the habit of writing that in descending order. So I'm going to make this a little bit smaller. And I'm just going to rewrite it so that it's in descending order by exponent. So that would be 1/3 x cubed minus the 2/5 x squared minus the 5/3 x plus 2, final answer. Okay, this is not wrong. I will not take off points for that unless the directions specifically say write it in descending order. But that is the right answer as well as what is in my box. All right, and then part D, we're going to do that division. All right, so I'm taking my f of 2 and dividing it by g of 2. Notice that this is not an x. It's not f divided by g of x. That is something different. I am actually plugging in a numerical value for x, and that number is 2. So what does that look like? That looks like everywhere I see an x, I'm going to put a 2. And this will just make our life a little bit easier to get a final answer that's a number and not an expression. So that's going to be f of x, but really f of 2. So that's 1/3 times 2 minus 2/5 divided by g of 2. That's x squared, so 2 squared minus 5. This next step I'm going to do is I'm going to try to simplify as much as I can. My denominator is going to be really easy to simplify. I know that 2 squared is 4, and 4 minus 5 is a negative 1. In my numerator, I'm going to go ahead and multiply out my 1/3 times 2 to give me the 2/3 minus the 2/5. At this point, because I need to combine those fractions, I'm going to make them have like denominators. So what is the common denominator for 2/3 and 2/5? Well, that would be 15, right? So if my common denominator is 15, I'm going to go ahead and rewrite that. That would be multiplying by 5, so that would be a 10. That one would be multiplying by 3, so that would be a 6. And still over that negative 1. And now I can actually combine my numerator. 10 over 15 minus 6 over 15 is giving me 4 over 15 divided by a negative 1. And so we know that we can multiplying by a negative is the same, or I'm sorry, dividing by a number is the same thing as multiplying by the reciprocal. The reciprocal of -1 is still -1, so this just turns into a -4/15 as my final answer. And the last ones look a little bit different, but it's the same process. So notice in part E, it's saying, what is f of x plus h? We don't have a function named h. We're not doing f of x plus h of x because we don't have an h of x. What's inside the parentheses is called the input. So whatever we see inside those parentheses in function notation is going in the place of our quote unquote x. It is the input value. So that just means I'm taking the function of x, which is that 1/3 x. Well, what's my x? It's x plus h. And then minus that 2/5. And so what I'm going to do is I'm going to distribute that 1/3. So I get 1/3 x plus 1/3 h minus the 2/5. I cannot combine anything here. This is my final answer. Everything is reduced, everything is combined appropriately, so it's done. Okay, so don't confuse any kind of operation within the parentheses for your input with a operation of functions. All right, same kind of thing happening in part F. So we still have that f of x plus h, which is the problem that we just did, but now we're subtracting the function f of x. So I'm going to go ahead and write, I know that first part is the answer that I just got, 1/3 x plus 1/3 h minus 2/5, but I'm subtracting the entire function of 1/3 x minus 2/5. Make sure you distribute that negative. Extremely important. That's where we see majority of our mistakes happen with this kind of stuff. Okay, so if I do that, I have my 1/3 x plus my 1/3 h minus my 2/5 minus a 1/3 x plus a 2/5. I distributed that negative, that subtraction sign. Now I can combine like terms, and I notice that things start to cancel out. A positive 1/3 x and a negative 1/3 x, a negative 2/5 and a positive 2/5. All I'm left with is that 1/3 h. That's all I'm left with, that 1/3 h. All right, so we talked about operations, adding, subtracting, multiplying, and dividing. And so now we're going to get into something called compositions of functions. Compositions of functions. And there's two ways that we notate composition of functions. Sometimes we will use this little open circle, this open dot. That is not a multiplication symbol. That is a composition symbol, and we read that as g of f of x. And that's exactly how we read it in the second notation as well, g of f of x. That means I'm putting the entire function f of x into, it is the input of the function g of x. Okay, and we could also obviously flip that around. We could say f of g of x, which would be the same thing as saying f of g of x. So sometimes we say fog and golf because it looks like that, but not really, that's a joke. Okay, but this is composition, and you're going to see both of those notations being used, so just be aware of that. So we always want to start with what's inside the parentheses because that is our input. So here we are starting with what is g of 2. Notice we are given new functions, so a new f of x and a new g of x. So I'm starting inside of my parentheses, and I want to know what g of 2 is, because g of 2 is going to be the input for the function f of x. Okay, so g of 2 is going to be 3 times 2 squared. And I'm going to put that inside of my f of x function. So following order of operations, parentheses, exponents, multiplication and division, addition and subtraction, I'm going to say, well, what is 2 squared? And that's 4. And what is 4 times 3? That's 12. So now I'm really focused on f of 12. All I did was simplify what was inside my parentheses. So when I want f of 12, then that means I'm going to plug in 12 everywhere I see an x in the f of x function. which is x plus 4. So f of 12 is really 12 plus 4, and 12 plus 4 is 16. So that f of g of 2 is really equal to 16. Okay, let's try it again. In part B, we want g of f of 1. So that means I need to start with f of 1. So I plug in 1 for my x in the function of f. Well, that's just 1 plus 4. So f of 1 is 5. So now I'm looking for g of 5. So if I plug in 5 into my g of x function, then that would be, g of 5 would be 3 times 5 squared. Well, 5 squared is 25, and 25 times 3 is 75. So that means my answer is 75. Always start with the innermost parentheses and then work your way out. Okay? All right, and then notice down here, we have the compositions of just the functions. So we're not going to get just a numerical answer. We will get some kind of expression answer. So this is reading in part C, f of g of x. So I'm taking all of that g of x function and I'm plugging it into the f of x function. So it's really like saying f of 3x squared because that is my g of x function. So everywhere I see an x in my f of x function, I'm going to replace it with 3x squared. So that would be 3x squared plus 4. And can I combine any of those terms? No. So that is my final answer. Doing the opposite, now I want g of f of x. Well, that's really like saying g of x plus 4. So I'll put in x plus 4 everywhere I see an x. So that would be 3x plus 4 squared. Okay? Now, side note, hopefully you know by now, and this is something that we're going to harp on all year long, that x plus 4 squared is not x squared plus 16. Okay? You don't just square the first term and square the second term. X plus 4 squared is really x plus 4 times x plus 4, and guess what? When you multiply two binomials, you have to use that FOIL process or that box method or whatever you use. So that would really be like x squared plus 4x plus 16, which would be x squared plus 8x plus 16. Okay? Not the same thing. So hopefully that's something that your Algebra 1 teacher harped on you, because that's something that we're going to harp on our kids as well. And so I kind of just did the side work there. So 3, that was x squared plus 8x plus 16. And if I did that too fast, I apologize. Go ahead and rewind, pause, or, try to work it out yourself. And then, because I've already done my x plus 4 squared, I've written out the trinomial here. Now I can go through and distribute that 3. So I get a 3x squared plus a 24x plus a 48. I cannot combine any of those terms, and that is my final answer. So we've done our 4 operations, adding, subtracting, multiplying, dividing. We've done our compositions, so putting one function inside of the other. And so now we're just going to be kind of practicing everything and looking at it in different situations. We could look at it on a graph or on a table or just using equations that are given to us. So here we go again. We have these two new functions. F of x is equal to 3/4 x minus 2/3, and g of x is equal to 4/5x plus 3. And we need to use those two functions for the following a through f. Okay, so we have a couple compositions. We have some operations. So here we go. So the first one, we want f of g of -5. So I'm starting with my innermost parenthesis, which would be g of -5. So I'm going to plug in -5 for x everywhere in the g of x function. So that would be, let me see if I can change my color. G of -5 would be 4/5 times -5 plus 3. Well, 4 over 5 times negative 5 would be negative 4, and negative 4 plus 3 would be a negative 1. So this is negative 1. So now I'm really only finding f of negative 1, which would look like 3/4 times negative 1 minus 2/3, which would really just be negative 3/4 minus 2/3. Right here, I need to find a common denominator between negative 3/4 and negative 2/3. That common denominator is obviously going to be 12. And so this becomes, I'll come up here, this will become negative 9 over 12 minus 8 over 12. And now I can combine those two and I get a negative 17 over 12. I can leave that as a reduced improper fraction. You're going to learn that I write kind of really big, so my work might get all over the place, and I apologize for that, but I will try to keep it as neat as possible. All right, let's go to the next one. So again, we're doing g of f of 6. So I want to start with my innermost parentheses, f of 6, so I can go ahead and evaluate that. So that would be 3/4 times 6 minus 2/3. Well, 3/4 times 6, so that would be, my brain just stopped working for me. Okay, let's see. So that would be 18 over 4? Yeah, 18 over 4, which would reduce to 9 over 2 minus 2/3. And so here we are again, stuck, got to get those common denominators. And so our common denominator here would be 6. So changing that, that would be multiplying by 3, so that would be 27 over 6 minus multiplying by 2, so that would be 4 over 6. And then combining, that would give me 23 over 6, and that is my reduced improper fraction. So let me go ahead and make all of this kind of smaller so I have room for my other part because I'm not done yet. All right, so now I'm taking g of 23 over 6, plugging that in. So that would be 4 over 5 times 23 over 6 plus 3. Okay, and so I know that gets a little ugly, but when you multiply fractions, you can multiply top times top and bottom times bottom. So you might have to take out your calculator, but this is going to give us 92 over 30 plus 3. And so then what I can do is I can actually reduce that fraction. 92 over 30 reduces to 46 over 15. And then I can write 3 as a fraction of 15, which would be 45 over 15. And then I can combine those fractions together to get my 91 over 15 as my final answer. And I know that's a lot for some of you to do pretty quickly or in your head, so feel free to take out a calculator if you have one or whatever. Pause the video, make sure you are checking my work and understanding where I'm getting all these numbers from. Okay. Then we're going to just f of g of x. So we are going to be ending up with an expression as our answer and not a numerical answer. So I'm taking the whole g of x function and putting it inside of the f of x function. So that's really like f of 4/5 x plus 3. So that's really like 3/4 times 4/5 x plus 3 minus 2/3. So what I need to do here is I need to distribute that 3/4. Oh, boom, boom. So 3/4 times 4/5 is going to give me 3 over 5x. And then 3/4 times a positive 3 is going to give me a positive 9 over 4. And then I still have that minus 2/3. So right now, I just need to combine those constant values, the 9 over 4 and the 2/3. So I need to create a common denominator. My common denominator is going to be 12. So I have my 3 over 5x plus, making these fractions of 12. I would have to multiply the first one by 3, so that's going to give me 27. I would have to multiply the second one by 4, so that's going to give me an 8 over here. And now I can combine those, and my answer is going to be 3 over 5x plus 19 over 12. Awesome. Okay. Yes, I know we're incorporating a lot of fractions. We want to do that right in the beginning so you're not scared of them. A lot of people are scared of fractions. It's okay. It's okay. Relearn those basic skills if you need, how to multiply fractions, how to divide them, how to add them, how to subtract them. We need those skills in the forefront of our brain because we use them all the time. Okay, nothing to be scared of, excuse me. All right, going into part D, g of f of x. So kind of the same thing, but flip-flopped. So I'm taking all of f of x and I'm putting it inside of g. So I'm really wanting g of, let me scroll down a little bit, 3 over 4x minus 2/3. And so rewriting that, that'll be 4 over 5, 3 over 4x minus 2/3, and then plus the 3. And so as you guessed it, my first step is distributing that 4 over 5. So 4 over 5 times 3 over 4 is a 3 over 5x. 4 over 5 times that negative 2 over 3, that is going to be a negative 8 over 15, and then plus my 3 from the outside. Lucky for me, I don't really have to find a common denominator. I just need to make 3 a fraction of 15. And so that'll be 3 over 5x minus 8 over 15 plus a 45 over 15. And so now I can combine those two fractions and get, I'm going to make this a little bit smaller, but 3 over 5x, and then that would be a plus 37 over 15. I'm sorry, I'm writing all over the place, but let me make this a little bit smaller. And so now we can see it all. Technical difficulties. There we go. Much better. All right. Now the next one looks a little weird. We're actually putting g of x inside of g of x. It's g of x. So I want g of 4/5 x plus 3. So I'm going to do 4/5 of 4/5 x plus 3 plus 3. I know it looks so weird. So you're putting the function inside of its own input. Kind of weird. But same process. We're going to distribute that 4 over 5, and then we're going to combine like terms. 4 over 5 times 4 over 5, that's like 4 over 5 squared, which would be 16 over 25x. 4 over 5 times 3 is going to be a plus 12 over 5 plus 3 again. And so all I need to do is make 3 a fraction of 5. So I have 16 over 25x plus 12 over 5 plus 15 over 5. And then combining my fractions, let me make this smaller again. And so our final answer is going to be 16 over 25x plus 27 over 5. And the last one in this section, f of x plus h minus f of x. So remember, the x plus h is not a operation of functions. It is your input for the function of f. So I want 3/4 x plus h minus the 2/3, and then I'm minusing the entire function, 3/4 x minus 2/3. So I definitely want to distribute my 3/4, and I definitely want to distribute my negative here. So that's going to be 3/4 x plus 3/4 h minus 2/3 minus 3/4 x plus 2/3. And now check out how easy our lives are. Combining like terms, positive 3/4 and negative 3/4, negative 2/3, positive 2/3. All I'm left with is that 3/4 h. And I'm wondering if you see a pattern there, because we did something the exact same setup earlier on up here. Let me find it. This one. Okay. Same thing. You're going to start to see a pattern with those. If I'm doing an f of x plus h minus the function of f of x, you're going to notice that we're only left with kind of that h value. Okay. We're going to do a lot of those. All right, moving on to example 4. Now we're using a table. Okay, so I'm not giving you the two functions. I'm giving you a table of their what's the word I'm looking for? Values. Whew, all right, values. So this is combining operations and composition. So we have f plus g of 1. So that means I'm taking, that's another way of saying f of 1 plus g of 1. This is an operation. So we're going to find f of 1. F of 1, my x value is 1. I want that f of x value, that's 3. Plus g of 1, my x value is 1. What's that g of x value? 4. What's 3 plus 4? 7. Okay. So finding the x value and then looking, am I looking for the f of x or the g of x value for that? Okay. Make sure you understand that table and how it works. I would suggest in the beginning rewriting these operations just to help you out that f minus g of 3 is the same thing as f of 3 minus g of 3. So again, my x value is 3, so I'm looking at this column right here. F of 3 is 0, g of 3 is 6. 0 minus 6 is negative 6. Part C, breaking that apart, f times g of 2 is the same thing as f of 2 times g of 2. So my x value is now 2, so I'm looking at this column. F of 2 is 2 times g of 2 is a negative 3. So 2 times negative 3 is negative 6. Okay, super easy if you can read the notation correctly and if you can read your table correctly. Now we're going to get into some compositions. So the first one I have is g of f of 3. So I'm going to do my innermost parenthesis first. So what is f of 3? F of 3 is 0. So now I'm going to perform this operation. What's g of 0? 7. Step by step. Second one is f of g of 1. So remember, another way of writing this is f of g of 1. Innermost parentheses first. G of 1 is 4. So now I'm really only doing f of 4, which is 2. F of 1. Innermost parentheses. What is f of 1? It's 3. So what is f of 3? It's 0. F of g of 4. What is g of 4? 0. So what's f of 0? 5. And the last one, g of 4. So what is g of 4? 0. So what's g of 0? 7. Last thing we're going to do is use graphs to evaluate the same kind of thing, the compositions and the operations. So this first graph is your f of x graph and the second graph is your g of x graph. So I want f of g of 0. So I need to start with g of 0. So g of 0, when x is 0, what's the function value? It's 2. So what is f of 2? Well, now I go to the other graph. When x is 2, what's the function value?